Welcome to Study Life. In this session of kinetic theory of gases, we are going to talk about our very important and very favorite Avogadro. Avogadro in the year 1808 started working on this law, and he actually took a lot of time to create this. Avogadro law simply says that the volume of gas is directly proportional to the number of molecules in the gas. That means if I decide to increase the number of molecules, my volume of gas is going to increase. If I decide to decrease the number of molecules, the volume of the gas is also going to be decreasing. How did he quote this? He says equimolar gases. He says equimolar gases will have equal number of molecules. Will have equal number of molecules. A very simple statement, but it actually had a good lot of meaning. Let's see. It says equimolar gases will have equal number of molecules. This is a kind of collaborated with Dalton's law. What did Dalton's law say? Dalton's law said if I've got two gases, both of these gases have the same number of molecules, the volume occupied by these two gases will be same. Also, the properties, if you focus, are different for the two gases. The same line was repeated by Avogadro. Avogadro said if I've got two gases with the same number of molecules, the volume occupied by them will also be the same. So for an instance, if I have got hydrogen and I've got oxygen, 1 mole of hydrogen and 1 mole of oxygen, right? So 1 mole of hydrogen will have Avogadro number of molecules of hydrogen. 1 mole of oxygen will have Avogadro number of molecules of oxygen. So this is all based on this relationship. Now, number of molecules, okay? It's kind of related to number of moles. So can I just write it down? V is proportional to N, where N is equal to number of moles. I increase the value of number of moles, my volume is bound to increase. If I decrease my value of N, my volume is also going to decrease. This relationship also says that if I take a ratio of V1 to N1 and ratio of V2 to N2, this is going to remain constant. Both of these ratios are same and they are always going to remain constant. Avogadro's law has played a very important role in the research with chemistry and physics both. Here, this man gave us a very important number. All of us know this number. It's Avogadro's constant. What is the value for this? It is 6.022 into 10 to the power 23. He says that 1 mole of any substance, 1 mole of any substance will have this number of particles. This value is fixed. This won't change. So if it's 1 mole of hydrogen molecules, it is going to have 6.022 into 10 raised to 23 molecules of hydrogen. If it has got 1 mole of sodium atoms, that means it is going to have 6.022 into 10 raised to 23 atoms of sodium. So I suppose the idea with Na or Avogadro's number is very firm, very clear. For entrance purposes, you will be using it as 6 into 10 to the power 23. You won't use this decimal numbers over here. I suppose everyone's now very familiar with Avogadro's law and the story with Avogadro. In the next session, we are going to talk about a grouping of Boyle's law, Charles' law and Avogadro's law together and making an altogether big, very important equation. Okay? So until then, stay tuned with Study Live and keep learning with me. Thank you.